So now we're going to go to boron. Boron. Now, I told you the first two columns of the periodic table will help us keep up with where the S sublevel is. Boron's outside the S sublevel region, at least of our periodic table. Okay? Boron's over here. We're going to get to a new sublevel over here. This is the P sublevel region over here. Remember, helium best belongs over here. We're talking about sublevels and things. So all this stuff over here is in the P sublevel region. Okay? So with boron, we're still going to have all these electrons. Every time you come to a new atom, you build it on what you had with the previous atom. Sort of, kind of. Okay? So let's put the same thing we have here. Well, I should have made that red like I did before, but oh well. Alright. Notice that I can only get 2 electrons in an orbital. We explained why. Opposite spins, right? Over here, in the P sublevel region, I'm not going to have just 2 electrons. I'm going to have 6 electrons in the P sublevel region when I get to neon. So how many orbitals do I need to handle 6 electrons? 3 of them, because they only put 2 in an orbital, right? All right. So when I get to 2p, okay, we're still in the second primary level, right here, second row of the periodic table. That's this second circle up here in the physical science illustration of the atom. Okay. And I'm going to have, and I can have a total of 8 electrons in that second level. So I can only put 2 in S. I need 3 more orbitals to handle the remaining 6. So we're going to put those 3 boxes side by side. Okay. All right. And I only need 1 more electron. So we'll put that 1 electron upspin in the first box. How are we doing? You with me okay?
Because neon needs 6 more. It has to have 3 orbitals.
Well, neon yes. Right. Well, 5 more than boron, but 6 more than beryllium, yes. Okay?
Why are you including neon in this?
Well, we're talking about where we're going to. Okay? So here's the reason we need 3 boxes. Once we get to the P sublevel, and if any P orbital appears, the other 2 are also appearing, even if they're empty. Okay? Once you get to the P sublevel and put even 1 electron in there, there are going to be 3 orbitals, even if some of them are empty. Are you with me so far? Now, we don't have to understand all the physics involved in why that happens. Okay? Just know, once we get to P, you got to have 3 orbitals. Fair enough? And if you want to, if you need to explain it to somebody or to yourself, or you have one of those, inquiring minds want to know. That's a yellow sheet. You know what a yellow sheet is? Oh, never mind. It's a slogan for one of those supermarket tabloids. Inquiring minds want to know. Y'all never saw that? Oh well, never mind. Okay. All right, so boron is there. Now, electrons can become entangled. I can get 2 electrons in the same orbital. But if they don't have to, they won't. Okay? If they don't have to, they won't. So, when we get to carbon, this next electron in the P sublevel is going to choose to be in a different orbital and not in this orbital. Okay? Think about it like this. Let me tell you a story. Can I tell you a story? All right. It's called the school bus rule. I want you to think about it this way. First day of school, first grade. Okay? You have to ride the bus. First day of school, first grade, you have to ride the bus. And you're the first person on the bus route. You get on the bus, nobody's there, you're going to move where? Where are you going to sit? First seat, probably because it's easy, right? All right. Next person on the route, you don't know. Where are they going to sit? Second seat. They don't sit next to you. They don't know you. You might beat them up. Okay? Third person on the route don't know you. Where are they going to sit? Third seat. That make sense? Right? Okay.
How do you know they don't have the second seat?
I'm just saying. That's my set of rules here for the school bus rule, okay? Trying to help you understand this, all right? All right. Now this is a strange school bus because it only has 3 seats. Okay? Only got 3 seats, but 2 people can sit on a seat. All right? Fourth person on the route. Where are they going to sit? Huh?
Somebody. They get to choose.
They don't know anybody. Nobody knows anybody. They get to choose. They don't know anybody, and they all look, equally, nice or whatever. They're just going to sit next to the person on the first seat. Make sense? Right? Kind of like how this works. As long as we have an empty orbital, the next electron in here is going to go to that empty orbital. Once we have one electron in each of these orbitals, then the next electron is going to join up in the first one. Right? Got it? School bus rule. All right. So let's do carbon then. See how that plays out. 1s, 2s, and 2p. Okay? One orbital in the s sublevels, 3 orbitals in the p sublevels. Okay? First 2 orbitals filled up with 2 electrons. Opposite spins because of their quantum entanglement. Okay? When we get to the p sublevel then, I've got 2 electrons to put in there. And like the poor little first grade kids on that bus that don't know anybody, they're going to choose to sit on opposite seats. Separate orbitals. Okay? This one's going to go here, like in boron, and this one's going to go here. Got it? I bet you, based on what you know now, can do the orbital notation for nitrogen, can't you? No?
We can try.
All right, what's the next one? Right after carbon. There it is, nitrogen. Try it. Try it, you'll like it. Let Mikey try it, he'll eat anything. That's a really old commercial. All right. From the looks of the pencils going down, I'd say y'all must have it figured out. All right, so here's nitrogen. There's my colon. 1s, 2s, 2p. Okay. I need 6 orbitals. I have 6 electrons for the whole section. I need 3 orbitals. At least in p. Okay. All right, we're going to fill the first one up. First, primary energy up. Going to fill up the first primary energy level the same way we did with helium. Fill both these up. The second primary energy level we're going to fill up like beryllium. Fill both those up. Okay. Just like carbon, we put 2 electrons there, and because these first graders getting on the bus that don't know anybody, they're going to be sitting in 3 separate seats. Oh, how hard was it? And where does the next electrons for oxygen go to? First one, down spin. Okay? Got it? Write oxygen then. Now I do these half arrows because it's just faster, okay? It's not going to blow anybody's mind. Y'all going to be okay with I do half arrows. It's just fast, okay? So carbon puts 1 electron in each of the orbitals. The next electron's got to go to one of these orbitals, so it's going to go down spin right there. There's oxygen, right? All right, fluorine. and neon. I only got one more place for it to go. It's full. Okay. So, give you a quick heads up about the next, not this unit, but the next unit. Full orbitals are more stable than half full orbitals. Okay? So that quantum entanglement makes an atom more stable. When I have all the orbitals full, that makes a more stable atom. Neon then doesn't bond with other atoms, typically, because it's about as stable as you can get them. Okay? What we're going to find out when we start doing bonding, particularly covalent bonding, is when I have orbitals that are only partially full, the covalent bonding occurs to fill up that orbital. Okay? All right, guys, you can pack up. Test tomorrow. Y'all have a good day. Be safe. Stay warm.